Hey there, Mr. Weaver here, and this is Topic 4B, Lesson 6, Systems of Inequalities. After this lesson, you need to be able to graph a system of inequalities, and you need to be able to determine if a point is part of the solution set. You'll know you're successful after this lesson if you can graph the system of inequalities and check if points fall in the double shaded region or on a solid borderline. A system of inequalities is a set of two or more inequalities with the same variables. It's similar to a system of equations that we saw in the last unit. So here we can see we have two inequalities. 2x plus 3.50y is less than or equal to 150, and x plus y is greater than 10. Two different inequalities, but they use the same variables. For these, the solution set includes the ordered pairs that makes all of the inequalities in the system true. Usually it's going to be just two inequalities, but it could be more. So any coordinate that makes both of the things true at the same time. And when we're graphing, which is an easy way to see where all of the solutions are, the solution set is represented by the intersection of the shaded regions. So like where the two shaded regions overlap. I call this the double shaded region, or the double shaded area. Let's look at an example of a system of inequalities. We're given y is greater than negative x minus 3 and y is less than 2x plus 2. If we were to graph these, so if I graph that first one, it looks something like this. Remember from the previous lessons that graphing with two variables, we draw the line and decide if it's going to be a solid line or a dashed line based on the symbol, and then we shade above or below based on what y is. So here y is greater, it's shaded above, and it's greater than or equal to, so it's a solid line. The key part to notice here is that it is shaded above. If we look at the second one, y is less than 2x plus 2, we graphed the line, it was dashed because it's just a greater than symbol, and y is less, so shaded below. Again, it's important to notice that here it's shaded below. For this to be a system of inequalities, we need to graph both of them on the same coordinate plane. So if you notice, there are some parts where it's shaded above the line in gray, and other parts where it's shaded below a line in red. Our solution set is going to be the area that fits both of those at the same time. So it's shaded red and shaded gray, indicated here with that pink star. Now, I also included some pink lines because the border of that shaded region is important. If the border is solid, like it is down below, a point could be on that line. Just like before, solid lines count when we're looking for answers. The other border line, where it's between the gray and the red, it is a dashed line because that red line was dashed. If a point falls on this line, it can't be part of the solution because it's a dashed line. We'll look more into this in the next example. Now it's your turn. Pause the video and graph the two inequalities. Lightly shade each individual inequality and then shade darker where they overlap. Use Desmos if you need help graphing the lines or to double check that you did stuff correctly. Let's check. So your first inequality should have looked like this. Your second inequality should have looked like this. Put them together, we can see the double shaded region at the bottom. Let's look at the next example where we're going to determine if some points are part of the solution set. So first, let's graph our system of inequalities. If I graph 4x minus 2y is less than 16, and graph x plus 2y is less than or equal to 6, my system of inequalities looks like this. Again, I want it to be in that double shaded region where the gray area and the red area overlap. Let's determine if the following points are part of our solution set. If they are going to be part of the solution, they need to fall in that double shaded area or on a solid border line. So let's check the first one. We have 4, 5. If I plot that point, it falls within the gray area, but not the red area. It needs to be in both. So that would not be a solution. If we check the next one, this ends up being on the border of our double shaded area. Because it's on a solid border, it's okay. So that second point of -2, 4 works. It's on the solid line that's the border of the double shaded area. If it had fallen on the solid line, such as this red dot over here, yes, it's on a solid line, but it's not on that border of the double shaded area. It's outside. It's nowhere in the gray at all. This red point would not be a solution. Even though it's on a solid line, it doesn't fall in the gray at all. All right, let's check the next. 2, -4. This time, it is on the dashed line that's on the border of the double shaded region. So it clearly falls within the red. It's on the edge of the gray, but because it's on that dashed line, it is not a solution. Dashed lines do not count. And finally, if we check the last point, 8, 4, it is not in either shaded region. It is not a solution. So the only one that, when we graphed it, was in the double shaded region or on that solid border line was -2, 4. Now it's your turn. Once again, pause the video, graph the system of inequalities, and check. Are the following coordinates in that double shaded area? Use Desmos if you need it. Check your answer. First, your system of inequalities should have looked like this. Our double shaded area that we want to look for is going to be up top and to the right. If we were to check each coordinate, the first one, 4, 4, falls within the double shaded area. The second one, -3, 2, is in one shaded area but not the other. Third one, 2, -2, is on the dashed line, so no. And 7, 1 is in one shaded area but not the other. So the only one that you should have picked was 4, 4. In this lesson, we learned about systems of inequalities, where it's two or more linear inequalities graphed and shaded in the same coordinate plane. Your solution set is where it's true for both inequalities, and this is the double shaded area. This is similar to the AND statements for compound inequalities, where it must be true for both things at the same time. Similar to what we saw in previous lessons, if it falls on a dashed line, it cannot be a solution, but if it's on a solid line, and that solid line was the border of a double shaded area, then it can also be part of the solution set. So there's two places you need to look for your answers: in the double shaded area and if the border edge is solid. After this lesson, do you now know how to graph a system of inequalities? And can you determine if coordinates are part of the solution set? If you're not sure about those things, go back and look at the different examples. Use Desmos to help you figure it out, focusing on where to look for solutions to be true. And that's the end of lesson 6 on systems of inequalities.